This lesson will teach me to factor by grouping. When you factor by grouping, you use this method when there are 4 terms in the polynomial. Factoring by grouping is an extension of factoring using greatest common factor. If you look at the problems below, they each have 4 terms. If I were to ask you what is the greatest common factor of the polynomial, some of you would say, well, it's a 5. Yes, but those don't have 5, so that's out. Some of you would say, well, it's a 6, or it's a 4, but that value is not in everything. And then some of you will even go to say, well, what about x? Well, I could take an x out of these terms, but not out of the end. There's no one factor that can come out of all 4 terms, which is why we need a new method. To factor by grouping, you're going to begin, as the steps say here, by placing parentheses around the first 2 terms and by placing parentheses around the second set of terms. Notice that that plus is including in the second set of parentheses to indicate that it is a positive 6x. Now we're going to go ahead and use greatest common factor. What is the greatest common factor of the terms that are in the blue set of parentheses? 5 and 20 both have a 5 in common. I can take an x to the third out of both sets as well, or as both values as well. What's left? If I take a 5x to the third out of each, I'm left with a 1x, which you don't need the 1, plus 4. Now, what's the greatest common factor between the 6x plus 24? They each have a positive 6 in them. So if you take out the plus 6, you are left with x plus 4. So that was step 2. We put parentheses around the first and second terms, first 2 terms and second 2 terms. We took the greatest common factor out of each. Notice we have what are kind of like leftovers, and it says put the GCFs in one parenthesis and the leftovers in another. These black parentheses are what they have in common. If you think about doing greatest common factor one more time, what does this section have in common with this section? Well, they each have that black set of parentheses. Picture taking this black parenthesis out. What would you have left? You'd have the 5x to the third. Picture taking the black set of parentheses out and lifting it off the page. You'd be left with the positive 6. The greatest common factor of this 4-termed polynomial is x plus 4, and the values that are left over are 5x to the third plus 6. Let's try it again. We're going to put parentheses around the first 2 terms and around the second 2 terms. Here, note that the negative, that minus, is still in the parentheses with the 14x. The greatest common factor of the values that are in the blue parentheses. I see the only thing I can take out is an x squared. By doing that, I am left with 2x plus 1. Now, look at the green set of parentheses. What do they have in common? They each have a negative 7, and by taking out the negative 7, I've ensured that this black set of parentheses I'm about to write matches the other one. These two must match because they are the greatest common factor of the entire problem. So by taking out the black set of parentheses, we're left with that colored x squared minus 7. Students look at these problems and they kind of think, well, wait a second, what just happened? Remember, the purpose of factoring is to undo the multiplication. When you multiply 2 binomials, in many cases, let me just kind of make up a problem. In many cases, when you multiplied 2 binomials, you ended up with, well, you always ended up with 4 terms. But in many of those cases, the 2 center terms combined. Sometimes, depending on the problem, the 2 center terms would cancel. And sometimes, depending on the problem, these types of problems, you did all of your math correctly and no terms combined. This is us factoring those types of problems and undoing the multiplication from problems where the terms did not combine when you were doing multiplication. All right, so you've already seen 2. Pause your video and see what you can do with letter C. All right, go ahead and look at your answer. Does it match mine? If you notice in the first set of blue parentheses, I was able to take out the 3x squared. So when I divided each by 3x squared, I was left with 2x plus 1. In looking at the second set of green parentheses, the only value that I could take out, which really isn't anything, was a 1. But note that the two black parentheses have to match. So by writing the plus 1 shows that the greatest common factor was 1. Taking out what they had in common leaves me with 3x squared plus 1. So the answer, 2x plus 1 times 3x squared plus 1. The order of how you write them doesn't matter, so this order is just as correct as the one that I have circled above. Remember that multiplication is commutative, so regardless of the order that you multiply, you can get the same answer both ways. All right, letter D. Letter D can be a little bit more tricky, and you may not understand why until the end. Different teachers may teach this one different ways, but here's my way. We're going to approach the problem the exact same way. I'm going to put parentheses around the first two, and I'm going to put parentheses around the second two. Notice again that the plus is in the second parenthesis with the 40. What do the first two terms have in common? They have a 2m squared in common. 2m squared, 2m squared. That's going to leave me with 10m minus 9. All right, now the green set of parentheses. What do they have in common? They have a 4 in common, a positive 4. Don't let this negative goof you up. I still need it to be a minus 9 down here. So I'm not going to mess around with the signs at all. All right, so when I divide by 4, 10m minus 9. So we're good because the black parentheses are the same. I'm going to take that black pair of parentheses out. And then the colored parentheses is what would be left. 2m squared plus 4. Now at this point, students circle it and say, woohoo, I'm done. But look at this colored set of parentheses. Is there a greatest common factor in the colored set of parentheses? The answer is yes. They each have a 2 that needs to be taken out. So think about rewriting your 10m. And if you were to take out the 2, and I'm going to put it at the end here just so it doesn't look goofy squished in the middle, I'd have m squared plus 2. So this particular answer didn't just have 2 things that were multiplied together. It had 3 things. And whether you write it this way or the way up above, you need all 3 things multiplied together to get you back to the original answer. Remember, factoring is undoing the multiplication process. So what was multiplied together to get 20m to the third minus 18m squared plus 40m minus 36? Well, these two binomials were multiplied together, and that answer was blown up by a factor of 2. Look at this problem a different way. Let me erase some of my work here. Some students may look at this problem, and some teachers may ask you to, look at the problem first using a lens of greatest common factor. What do all 4 of these terms have in common? They all have a 2 in common. So this problem is really 10m to the third minus 9m squared plus 20m minus 18. And then from there, once you've taken out that leftover 2, then from there you're able to even group that answer. So whether you do the grouping first and the greatest common factor second, or whether you do the greatest common, grouping first, greatest common factor second, or whether you do the greatest common factor first and then grouping, let's see, what do these have in common? M squared. So m squared, 10m minus 9. These have a 2 in common, giving me 10m minus 9. So m squared plus 2, 10m minus 9, and that 2 from the beginning. So here what I did was I took out the greatest common factor first for the whole problem and then went ahead with grouping. What I did originally was I went ahead and did grouping and then took out the greatest common factor. Either way, it works out the same. There's an extra 2 in this problem that you just have to be aware of. All right, what does it mean to be prime? Give an example of prime. Well, in the previous lesson, we discussed that prime is when you have factors of only 1 in itself. That's all fine and good, but just make sure that when you are applying your definition of prime, you're not just thinking about greatest common factor anymore. You're now thinking of problems that not only don't have a greatest common factor, but ones that can't be grouped now either. So if you look at the first way we learned how to factor and the second way we learned how to factor and say, well, I can't really do either, then a particular problem would be prime. So let's look at some examples. Look at x plus 3. There's no greatest common factor. There's not 4 terms, so it can't be GCF'd. It can't be grouped, so this one is prime. What about something that looks like this? And I am totally making these up. They have no greatest common factor. They don't have 4 terms, so they can't be grouped. Here's another example. Is there a greatest common factor that goes into all 4? No. So then go ahead and attempt the grouping process. What can be taken out of the first set? An x squared. What can be taken out of the second step? Okay, well, let's take out a 1. No matter what you do regarding the greatest common factors for each set of parentheses, these 2 terms, which should be the same, won't be. This problem can't be grouped. It doesn't have 1 GCF for the whole thing, so it's prime. You reserve prime when you can't do anything else to a problem because it doesn't have any value other than 1 in itself. Thank you very much, and please let me know if you have any questions.